All right, friends, we're going to solve rational equations today. So instead of trying to make a common denominator and add things together or to multiply and divide, right, we're gonna get rid of these fractions, right? Because let's be honest, like nobody really likes fractions. I'll tell you I like fractions because like I know how to work with them, right? It's part of being a math teacher. You just find ways to deal with it. But the truth is, if we can eliminate them, that's what we're going to do. So I'm looking to see a common denominator. If this were like another plus sign or something right here, what would the common denominator be? It would be x plus 3 and x minus 3. If I had that in all three of these, then I could just get rid of all of it. So here's what happens. I'm going to write this out this one time, but then you're going to notice what happens so you don't have to do it anymore. So I'm going to take both of these guys here. I'm going to distribute to all three of these terms. So here's what we got. We got x times x plus 3 and x minus 3. What's it over top of? X minus 3. So what happens? There goes the x minus 3. I've eliminated the fraction. So do that again, plus x, x plus 3, x minus 3. As we distribute here, it's over x plus 3. And this time we'll get rid of x plus 3. So no more fraction. And it equals 2x plus 3, x minus 3, and it's over top of x plus 3 and x minus 3. So I'm going to change color marker here. All right, so we've eliminated all the fractions because we multiplied what would have been the least common multiple or common denominator, not to use too many terms at once there. So x squared plus 3x distribute over here. So you can imagine if I make this a minus sign right here, I want to distribute the negative like when we were subtracting. So be careful with that. X times x is plus x squared minus 3x, it equals 2. All right, well, that's not too bad. I got 1x squared and 1x squared. So I got 2x squared, 3 minus 3 x's, they're gone. Let's divide by 2. So x squared equals 1, and we'll take the square root of that. So x turns out to be plus or minus 1. Not too bad, right? We did all that work and we got plus or minus 1. Okay, only thing I want to watch out for is, no, I don't think we have to talk about restrictions, right? Okay. All right, let's try it again. So same thing we've been doing all chapter here. You're basically just going to factor things out. We're going to find out what a common denominator would be for the whole thing. So x plus 2, x plus 1. We're going to multiply by that whole thing, x plus 2, x plus 1. So here's how it looks in the shorter version, okay? So when I distribute over here, they're both going to cancel out. So I get just x minus 1 is left over plus 2x times. When I distribute here, the x plus 2's are going to cancel out. Now, I still need that for the next one, so I'm not going to scribble anything out, but I only have 2x times x plus 1. Okay, if you're not sure, just write it all in, equals, and then when I distribute on the third one, the x plus 1's cancel. So I'm going to have x minus 1, because that was originally here, and I'm going to have an x plus 2. So there's a little more left this time. There's a little more work to be done, but nothing you can't do. Okay, so we got to distribute here. So x minus 1 plus 2x squared plus 2x equals, over here I have to FOIL this. X squared, I get 2x minus 1x, so that's plus x, and I have minus 2. All right, the left-hand side is still a mess, so let me put that together. 2x squared, I got 1x and 2x, so plus 3x and minus 1 equals x squared plus x minus 2. I don't know what's happening with this. Yeah, I do. I just made that part up, right? Put everything into one side. I want to try and keep x squared positive. So I'm going to subtract x squared, subtract x, and add 2. Subtract x squared, subtract x, and add 2. And hopefully I'll get something factorable. If not, you're just going to see a grown man cry. I'm just kidding. I would use a quadratic formula. I'm not going to cry about it. Just saying. It'd be okay if I did, though. Right? Okay. All right. Factors are one that add up to 2, or x plus 1 and x plus 1. All right, so I'm not going to use a square root method like we did in the last one because, you know, it has this linear term in here. So factor it out, x equals -1. We would get that twice, not as important here as it is when we go to graph things. And put -1 in here. So we get x equals -1. All right, it says you can use your graphing calculator to solve these. We're not going to use that stinking thing. We don't need that. What you would do is you'd put this whole side in, and you put this whole side in, and you're trying to find where the two graphs meet up. And then you're going to look for the x values, right? Because when we get done, we say x equals, x equals. All right, but we're not going to use that here. Let's use this as a third example so you know what you're doing. 1, remember, is over 1. Right? So that's not going to add to my common denominator at all. So I need to use x plus 2 and x minus 2. So as I distribute this whole thing, the x plus 2's cancel. So 2x minus 2 plus x minus 2 cancels, so x plus 2. And it equals, now I need both of these, x plus 2 and x minus 2. Right, because the 1 doesn't cancel anything out. All right, it's identity property. That's okay. All right, let's distribute 2x minus 4 plus x squared plus 2x equals. I'm going to clean this up, right? I've been trying to do like every line in a row, but honestly, what I'd probably do is clean this whole thing up. X squared plus 4x minus 4 equals, let's see what happens over here. Oh, we have conjugates. So it's x squared. It should be a squared. We're going to get minus 2 plus 2, so they're gone, and then minus 4. So x squared minus 4. Let's see. Let's subtract the x squared and add the 4. Subtract the x squared and add the 4. So that what up? A lot of stuff going here, guys. So this is gone and equals 0. Oh, divide by 4. X turns out to be 0. All right, so same thing. Again, we can show this to you in class with Desmos or your graphing calculator, so we can check it that way. But that means we should have whatever these graphs look like, right? Like we know the right-hand side, y equals, that's a horizontal line, but it's going to hit at x equals 1, so we get those taken care of. All right, so homework is down below here. We'll work on that after our pair deck if you're in my class. If you're not in my class, you don't have homework. Well, not from me anyway. So I got a couple of these just using some variations. Don't forget there are some of these that you can just cross multiply, right? That would be the best thing to do, right? Put that over 1, cross multiply. And others, we're just going to multiply this whole thing by that common denominator so we can get rid of those items. Okay, but in this one, you're not going to do that, right? Because you're just going to add the 1 over MC over, so it's equals, because it was set equal to 0. So that's kind of crazy. All right, there was one other one down here I wanted to point out. Okay, so a lot of these aren't too bad. Oh, here it is. So just make sure if you do get two fractions that equal to each other, just cross multiply, right? I don't have to eliminate like I will over here, right? Over here, we're just going to multiply by that k plus 1 and k minus 2. Okay, but if it is something where it's two fractions that equal to, use your noodle and just cross multiply because that's a lot easier. All right, we'll work on it some more in class, and thanks for tuning in.